Next we'll be covering problem 4, which asks about the buoyant force acting on the chromium block. A couple different ways that we could think about how to approach this one. One thing that we used before was a free body diagram, which helped us to relate the buoyant force to other things around us. In that particular case, if you remember the problem, that was the swimmer problem. The swimmer was floating on the surface, and we found that the buoyant force and the weight were two forces acting on the swimmer at that time. Because the swimmer was at the surface and staying at the surface, we knew that the acceleration was 0 and therefore net force was 0, and that gave us enough information to use the swimmer's weight to find buoyant force. In this particular case, we will not be able to solve it using just a free body diagram like we did before. The reason for this is that we know that the chromium block is going to sink. Because of this, there are two possible scenarios. Either when we put it in the fluid and not on the floor of the container, in which case it's going to continue to fall and accelerate due to that falling process because it has a sinking tendency. That would mean that that force is not 0, but we wouldn't have a way to calculate that right now. And therefore wouldn't be able to use the fact that the buoyant force and the weight were the only two forces acting on it, because there'd be this other unknown of what the actual net force is. If it were then sitting at the bottom, that would make it so the net force is 0, because then it's staying still and not changing its velocity. But then we have the added problem that the ground, whatever surface it's sitting on, would be exerting some upward force on the block. That would be another unknown force which we could not account for at this point, and therefore lead us to problems with finding the buoyant force through that situation. So we're going to need to look for something different. What we can use in this case is the fact that we have found how much ethanol is displaced in the process of dropping the block under the ethanol. This is important because since we have the volume, that gives us a handle in that will help us to find other stuff about the displaced fluid. We know from the Archimedes principle that the buoyant force is very closely related to displaced fluid. So buoyant force is equal to the weight of the displaced fluid. That means that we need to start thinking about how we're going to find the weight of the ethanol here based on what we know. We know the volume. We're trying to get to weight, but at the moment we might not have a direct way to get between them. So we can do a little bit of planning like we would do with our dimensional analysis style problems, where we were thinking about what units we should use to get from one thing to the next, and that helped us along the way. We can do a similar planning process here. So what could we do with the volume that would bring us closer to weight? In this case, what we could do is convert that volume to mass. Mass, we know, is very closely related to weight, and from there we should be able to get to the weight. So now that we have a plan, let's start to implement it. We can find the mass using volume and density, both of which we have. So this equation, mass equals density times volume, that is something we can use. Plugging in our value for density, 0.789 grams per milliliter, and our previously found volume, which was 8,512 milliliters. We should be able to get to our density. By multiplying, we'll end up with a value of about 6,716, and our units will be grams, as the milliliters here cancel out. This will be good for us to go on to use in our formula to find weight, which we know equal to mass times gravitational acceleration. We do have one small issue, that the mass that we have to use to find a force in newtons should be in kilograms. That means we need to take our value in grams and do a conversion. So I'll take our number of grams, set up the proper conversion using a conversion factor relating grams and kilograms, with grams to be on the bottom and not to cancel, and then we'll plug in the appropriate numbers. 1 kilogram is 1,000 grams, to solve for the fact that we have 6.716 kilograms in this part. We are now able to go over to the weight formula, plug in our mass in kilograms, which is good, and and gravitational acceleration are 9.8 meters per second squared, and this will give us a value of approximately 65.8 newtons. We know that this weight is associated with the ethanol that's been displaced, and as weight of the displaced fluid, it should also be equal to our buoyant force. So that will serve as our answer for number 4, the buoyant force acting on the chromium block. So that takes us through most of the problem. We will have a little bit left to go in the next video, which will cover problem 5.